Most people have never met a paleontologist who believes in a young Earth. In fact, if you follow mainstream science channels, you'd think that person doesn't or even can't exist. But they do. And one of the most respected voices in that world is Dr. Marcus Ross. Today, we're going to talk to Dr. Ross about the science, the assumptions, the faith, and why the conversation about origins is so much deeper than people think. Dr. Ross, thank you so much for joining me. Let me start right here. What is the biggest misunderstanding people have about scientists who hold to a young Earth view?
That's a good question. I've spent a lot of my training and my time in non-Christian environments. As I said before, I was K through PhD in state schools. And the biggest misconception that I ran into going through, at least personally, was that you're a creationist because you're ignorant. That was kind of the default expectation of my undergraduate advisor, probably a bunch of folks that were teaching me in my master's degree. And by the time I got to my PhD, the folks that hadn't known me and been part of the process of bringing me on board into the department, I think that's frequently the default perspective, is that you're a creationist because you simply don't know better. And if you did know better, then you'll change your mind. And for my undergraduate advisor and for others that I've known, that was, I think, the first opinion that they had of me coming in. And when they eventually came to the understanding that I wasn't a creationist because I was ignorant, then you had some divergence of opinions. You had some people who were like, okay, he's got this like biblical perspective that does weird things, but he's an okay guy. And then when I was in my master's degree, on the other hand, there were people thinking like, no, he must be lying about things. Like we've told him how to think about things. He seems to know the facts, so he now must be wicked and evil and devious in some ways. That led to a lot of problems in my master's degree, and that was a real big issue for them. Was they felt that science could only move in one direction, and that was via methodological naturalism. So at least in my experience, that would be the big one, that you're a creationist because you're ignorant. And that means that for any creationist who wants to go into higher academia, that wants to go to college to master's degrees or PhDs and so on, you're going to have a lot ahead of you to try to show people that you're not ignorant. You're going to have to work hard, perhaps even harder than most of your colleagues who do hold to an evolutionary idea or an ancient age to the Earth, because they're not going to face the same kinds of headwinds that you are. They're not going to have the same things thought about them. You're going to have to be better in whatever it is that you can do. You can't be better at everything, but you can choose some things to excel in. And for me, in my master's, my PhD program, I wanted to be able to excel in evolutionary theory. I wanted to be able to understand that concept, those ideas that are out there, the various perspectives within it, as well as I possibly could, and better than all my colleagues, because of that kind of initial prejudice or that initial conception about me. If you're going to be considered ignorant, you're going to have to do something. You're going to have to work very hard to overcome that. So that's what I would recommend for those who are thinking about going in to areas of evolutionary theory or old age geology. For students out there, what am I going to do? Study hard. Study harder than everybody else.
Yeah, and I mean, what people need to understand is you're a real scientist. This isn't, you're not a pseudoscientist. And so how do you go about changing these perceptions and creating opportunities for yourself?
Well, within academia, you've obviously got various kinds of metrics to kind of establish whether or not you know stuff. There's tests and quizzes and papers and presentations and those sorts of things. For the scientist, you get a lot of practice in those areas. There's a lot of content that you have to learn, and I don't say this to be flippant, but to regurgitate. Right? You got to take it in. You've got to be able to show somebody that you've learned it. So if you can excel in your courses, that is a big way of showing people that you have learned the material, and would then be a position that kind of opens you up to more personal questions from people outside of class. Okay, so why do you think the way that you do? And I had a number of occasions where that sort of thing happened with me in my undergraduate, master's, PhD. I remember especially in my PhD, one of the guys coming down the hall, he was a fellow graduate student, and the conversation was almost kind of like poking and prodding, like, okay, you seem like a normal human being. You seem like a rational guy. Why are you thinking the way that you do? Why do you have these doubts about evolution? Or why do you think that the age of the Earth is different? These were not things that I brought to the classroom. And I think that was important as well. As I didn't write my papers, I didn't answer my questions as a young Earth creationist. Going to the schools that I did, University of Rhode Island, Penn State University, the South Dakota School of Mines and Tech, those schools I always felt are training me to in a particular position. They're training me in a discipline that assumes certain things to be true. And I need to be able to show them that I can understand all of those concepts to the best of my ability, right? But that I can do well and that I can understand this system. And then if you have deviations from that system, if you disagree with that system, hopefully, the excellence in your work will open up the possibilities for discussion. And I had good discussions with my fellow graduate students, especially, right? Because you're shoulder to shoulder with them. You're in the labs together. You're in the offices together. You're teaching classes as a TA with them, those sorts of things. So I had some of my best conversations with fellow graduate students, and that's to be expected. They're your cohort. But I also had really good conversations with some of my professors in my undergraduate, a little less so in my master's program, and certainly in my PhD program. I had some very, very good conversations with folks. And those people, like my PhD advisor, who understood that my difference of opinion is rooted in the question of whether or not God exists and is capable of materially acting in the world, and whether he has done so in certain ways in the past. That initial place of division leads us to different kinds of possibilities. And so for my PhD advisor, who suspects that God does not exist and the world operates on purely physical, chemical sorts of rules, he's going to have a certain set of options available to him conceptually, right? Evolution is basically something that has to be true in some way, shape, or form. For me, as a Christian theist, I had more options open. Certainly, there are theistic evolutionists who think that God used evolution, but for me, looking at the Bible as an inspired and inerrant document given to us through by God through the prophets and the writers, etc., and written in a particular way that I think is telling us a historical series of events at the beginning of Genesis. My PhD advisor understood why my trajectory would bring me to this other class of possible answers. So, that was something that was really, really good, because when you realize that your initial philosophical ideas about God, about his existence, capacity to reveal himself to us, etc., are some of the things that are driving you in different directions, it meant that I could talk with these students who understood that, these professors that understood that. We could talk about all this surface level stuff about is this thing a transitional form, or what do you do about this aspect of radioactive dating, or what do you do with this sequence of evolution, or these concepts of evolution, punctuated equilibrium, Darwinian gradualism, neutral theory, these different sorts of things. We could talk about those things, and I could play the part of an evolutionist, so to speak, without them getting irritated, if they realize, okay, he's assuming our stuff, he's showing that he understands this. Now we want to ask, okay, so what about your perspective on something else?
So, Dr. Ross, you mentioned assumptions that underlie both your view and the methodology that you were going to school to learn. Can you talk a little bit more about that? The assumption that underlies what is behind your methodology or your view and behind the methodology you were learning in school.
Yeah, I think for someone like me and for many young Earth creationists, we recognize that God has supernaturally acted in the history of the world. Certainly, the Bible talks about all kinds of miracles that were performed by Jesus or the prophets, etc. But when we get to aspects like the early chapters of Genesis, God talking about creating the physical world, about creating mankind separate from everything else, from imbuing them with his spirit, for example, for events like the flood that are described as historical. For me as a young Earth creationist, those are historical tie points that need to be incorporated into the way that I think about Earth history. They are, in my mind, part of the data that are to be included in any what I think is going to be realistic and comprehensive understanding of our world. Going to the schools that I did, those are not included, right? The Bible is not considered anything that can speak to us in terms of science or history, especially deep history like paleontology, right? If I think that the world was created only a few thousands of years ago, and my program says, no, the world, began as a hot molten ball and solidified and cooled about 4.5 billion years ago or so, right? That's a big, big difference. And part of the reason for the difference there is that they're going to be extrapolating back certain assumptions about the world and interpreting certain data points. They're going to be relying on radioactive dating methods, dating not only of Earth rocks, but also meteors, all the things that go into establishing a chronological history of the Earth from the Big Bang to the present, including biological evolution, et cetera. All of those approaches, or all of that ideology, is rooted within a naturalistic approach to science. You don't have to be a full-blown atheist. Science often is working upon an assumption of what's called methodological naturalism. That is, that in science, we assume that nature is all there is and the forces of nature are all that are working in a particular place where we're looking, and that has been the case all through time. I can certainly agree with methodological naturalism as a basic operational principle for most science. I'm not expecting that if I'm in a chemistry class that there's going to be something really weird that happens when I put two chemicals together. I'm not expecting that angels are going to do something that the chemicals themselves will not normally do, because I think that methodological naturalism, in a sense, is kind of like God's providential upkeep of the world. Miracles are called miracles precisely because they are rare events that go counter to the normal operation of this world, right? They go in an opposite direction, or they're a confluence of events that are statistically so improbable. We look at it and say this is miraculous. But when it comes to looking deep into the history of the planet, I think that methodological naturalism is too restrictive, right? If I do think that the Bible is inspired and is providing us with data about the history of the world, I don't want to take that information and cast it aside and build theories away from it. I want to build theories that are built within it and incorporate it. That's the major difference between the way that you're going to get trained at a college and university versus if I think you're adopting a consistent and coherent biblical perspective and applying that within the context of science. And my aim and my goal is that when that is done, we will find ourselves closer to truth and be more robust in the way that we both do things and discover things.
Yeah, that's a major point. The idea that the disagreement isn't the data. You're not disagreeing in the data that you're observing. You're disagreeing in the conclusions that you're drawing from it. And the presupposition or the assumptions behind it is really dictating the outcome that you reach with that data for both sides. So in your field, what's an example of that playing out? Something that maybe is a big part of what you study and where you work in, that you can show how that actually impacts conclusions.
That's an interesting question, and so thanks for asking that. Getting to your statement about the data are the same, that's exactly what we try to teach students with, say, the geology kits that we produce here at Cornerstone Educational Supply. We've got a little insert of a geologic timescale, and right down the middle are all the names that one would expect if you opened up any book on geology. You've got Cambrian and Ordovician, Devonian, moving your way up. You've got Triassic, Jurassic, Cretaceous, all that sort of stuff. And on either side of that column, I show two interpretations. One interpretation of an ancient age of the Earth on the left, and on the right is an interpretation of the same data from a young Earth creation perspective of what rocks are formed during creation week or the flood or after the flood. I want people to understand that the data are the data, that I can go to a rock outcrop with another geologist who disagrees with me about geologic age, and we can both accurately observe the rock. We can identify the types of mineral grains that are in, what type of rock it is. Is it an igneous or sedimentary or metamorphic rock? We have to be able to agree on these sorts of things before we can have discussions about the hows and the whys that it's there, right? The first thing that we have to agree on is what it is. And in that way, I think young Earth creationists who might be listening take heart, because there's going to be a whole lot of things that you can agree with going through education or talking with folks online or talking with friends that you know about the world around you. It's not about disagreeing about what is the world. It's a disagreement about how the world came to be, right? So thinking about, what are some great examples of young Earth creationists that think outside the box like this? I think, probably one of the first couple of people that comes to my mind are Leonard Brand and Art Chadwick. Those are names that you don't often hear in creation evolution circles because they're sciencey guys that mostly do sciencey work, and they publish papers both in the secular literature as well as in the creation related literature. These are two guys that really think about how do I apply my understanding of creation to the world outside. Both of them have backgrounds as biologists and have also become geologists and paleontologists. They spent more of their time doing geology and paleontology work over the past 20, 30 years or so. They had a question, for example, about, hey, it seems to be that there's not very much what's called bioturbation in the fossil record. Bioturbation is when organisms in loose sediment dig around and stir up that sediment and tend to obliterate kind of the nice little layers that are formed. So let's say that you've got a storm or a hurricane that comes along the Atlantic coast. The waves will create nice little layers in the sand and the silt and the mud on the bottom of the ocean. As soon as everything's kind of calmed down again, organisms will start tunneling around and looking for food and things like that, and they're going to obliterate all those nice little layers. Well, if the geological record was formed over a very long period of time by processes more or less like what we see today, right, an assumption of uniformitarianism or the modern perspective of actualism, then we would expect there to be virtually no fine little layers out there because there's been too many organisms stirring up the sediment. Well, they started in the Grand Canyon and walked their way, basically to Wyoming, measuring all of the different layers of strata between the base crystalline rock and starting at what we call the Great Unconformity and working their way all the way up through the Cambrian and the Ordovician, through the Triassic, Jurassic, and Cretaceous, and into the Cenozoic, all the way up to the Eocene and the Green River Formation. And we're charting where they found minimal, moderate, and extensive bioturbation to ask the question of the rocks, is our intuition that bioturbation is rare confirmed by a serious study of the rocks? We are going to measure about, I think, 6,000 or 7,000 feet of sediment. And their study showed that little to no bioturbation was the absolute dominant situation in the rock record. It looks like the sediments were laid down faster than organisms could keep up with bioturbating them. And that is really different from what we see off the Atlantic coast, published in Chesapeake Bay, or things like that around the shallow marine environments that dominate the fossil record. Most of the sediments on the Earth right now, on the continents, for example, are shallow marine sediments. They're not terrestrial sediments. They're mostly shallow marine sediments. And in these shallow marine sediments, bioturbation is incredibly rare. That should not be the case if the Earth is ancient. So, there's just one really good example of a study that they just completed and just published their findings in New Creation Studies. They published their stuff in secular journals as well. They've been working at dinosaur dig sites and various other sorts of places. They're known in the geological community as good scientists because they're willing to do painstaking long-term work. And that's, to me, a great inspiration.
Yeah, thank you for that. One of the criticisms of young Earth creationism is that it doesn't make testable predictions. But you've argued that it actually does. Could you walk us through what kinds of predictions a young Earth framework makes and how those predictions line up with what we observe in science?
Yeah, so another study that was recently completed was worked on by Dr. Andrew Snelling and Dr. John Whitmore. Both of them are geologists. Andrew Snelling is what we call a hard rock geologist. He studies igneous and metamorphic rocks and the minerals that are in them. And Dr. John Whitmore is a sedimentologist and taphonomist. He studies sedimentary rocks and he studies what happens to organisms from the time they die to the time that we dig them up as fossils. Right. So that's the discipline of taphonomy. They were engaged in a research program as well in the Grand Canyon, looking at sediments, sedimentary rocks that are in these tight folds. And their hypothesis was that this fold in the rocks had to have happened without metamorphism, and that is without the altering of that sedimentary rock into something that looks somewhat different from what it used to be. And that it happened while the sediments were probably still semi-soft. So they had to get permits, and that was actually a chore. There was some folks at the National Park Service that were trying to hold them up because they knew they were young Earth creationists and they didn't want to give them permission. And it took the threat of a lawsuit and a senator stepping in and saying, no, you are the National Park Service. We have a proposal for a scientific research endeavor. It's a reasonable one. It doesn't matter if they're young Earth creationists. This is public land, right? So the National Park Service said, okay, fine, we'll give them the research permit. They went in, they collected their samples, they took measurements, hundreds and hundreds and hundreds of samples. They sent them off to a laboratory in order to be evaluated and turned into what we call thin sections. That's so that you can look at a rock under a microscope. You have to make them these super thin little things that light can penetrate through. And at the lab, they identify all the minerals that are in there. And right, again, the hypothesis was that this folding was happening without, not over deep time, not under temperatures and pressures that would have required the rock to metamorphose and change from its original form into something different. And they found that that was the case, right? So another example of geologists making predictions, going out to the data, collecting the data, having it analyzed, and presenting their results. This is what science is about. I think that's a good example of creationists doing scientific research. That research was published in Answers Research Journal, which is a young Earth creation journal. I would have liked to have seen more of it published in secular literature. I think that abstracts, posters at our major conventions would have been really good. That's something that Dr. John Whitmore, who was involved in this study, does all the time. He's at the Geological Society of America every year with students from Cedarville University, and they are presenting their research and their data. And John Whitmore does a lot of studies on what's called the Coconino Sandstone, which is a sandstone rock out in Arizona that has long been interpreted as being formed under Sahara-style dune-like conditions, dry dunes. He's been working on that unit for 15, 20 years now, bringing students every year out, collecting samples, and showing that there are features in this rock that indicate that it was formed underwater. There are minerals that are there that shouldn't be there if it was a Sahara-style dune. There are structures and features inside the rock that comport better with it being formed underwater than it being formed under air, dry kind of conditions. And he and the people that have worked on that are known in the scientific community for this perspective and position, and they make their case and they make their argument in the secular literature on this. So, when you do that in the secular literature, you can't always bring all the ideas that you want about, a young Earth or global flood or things like that, but you talk about what you can talk about. What is the nature and the features of the rock? How, what is the best interpretation of this thing? The rock is sandwiched between two units that everybody believes were formed under marine condition, and then there's the Sahara in between. Why would we think that? And here's some reason to think that it was formed underwater as well. And John chose that unit of geology because it was a challenge to young Earth creationism, because people were saying, listen, you can't have Noah's flood happening when the Sahara is out there. This is proof positive that in these rocks pretty low down in the geological column, they couldn't have been formed by the flood. And John thinks, well, maybe they were. Has anybody looked close enough? And he saw that most people just, took an interpretation that was made in the 1930s and 40s and just kind of, haven't updated it. They've just kind of assumed all the time that this is the way that it is. And he said, no, let's get closer. Let's look deep at this. Let's look at hundreds and hundreds of samples from scores of sites. And I say score, I mean it, like, 30, 40, 50, 60 different localities where they're collecting data. Young Earth creationism at its best is this type of work. It's patient, it is long-term, it is careful, it is presented both to the secular community, because that's where most of the experts are on these different topics, and to the creation community. And that can be done in biology, that can be done in astronomy, that can be done in chemistry, that can be done in paleontology. For those of us in young Earth creationism that want to see this happen, And I think that's all. All of us want to see good research happen. There's research that has to be done in young Earth creationism to make young Earth creationism better. There's also research that needs to be done to show other people outside that young Earth creationism is not as silly as they've been led to believe.
A huge thanks to Dr. Ross for everything he's unpacked so far. And listen, part 2 gets even better. We move from the public conversation into the internal one, the rise of the new creationist movement and the real progress that's been happening behind the scenes. You don't want to miss that. I'll see you in part 2. Until next time, stay shaped by reason, guided by faith, and grounded in Christ. Take it easy.